discuss about Fourier transform. As you can see, I have already written down the formulas, and I will dictate it. First definition, there are two definitions. I will use yellow color. Okay. First definition, I think this is not visible clearly, so I use violet. So first definition and second definition, there are two type of definition in Fourier transform. Fourier transform basically transform ft function of t into function of omega. Okay, so Fourier transform of f of t goes to minus infinity to plus infinity ft to the power minus I omega t dt, and I have noted down the inverse Fourier transform also. So this is 1 by 2 pi minus infinity to plus infinity g omega e to the power plus I omega t d omega. So note that in the first definition here is minus sign for the Fourier transform, and other one is plus. Recall this definition for the second definition. The second definition is similar to first definition, only the sign changes. So see, in the first definition we have seen Fourier transform of function of t is ft to the minus I omega t. So here will be plus and the opposite will be minus. One will be plus. The formula to remember this is, remember just one. For first definition it will be minus, and other will remember like that. And now you can see these properties. You can take screenshot also. Here parity does not change in Fourier transform. Okay, so integral form of Dirac delta function, I have noted it down, e to the power I omega t minus t0 d omega equals to 2 pi delta t minus t naught. One thing to remember this, that here comes the result of integration as function of t. So the integration will be over d omega. Okay. So similarly you can note minus infinity to plus infinity e to the power minus I omega t minus t naught d omega equals to 2 pi delta t minus t naught. Second definition using. I will show the proof if you want to know. Now you can see the table which you can remember for easy calculation. Okay. So ft is the function, g omega is the Fourier transform of the function ft, and this g omega is using first definition. First definition is what? First definition we have used minus sign in the Fourier transform of ft. So you can take screenshot of these formulas. So definition 1, using definition 1 we can find these formulas, and using second definition you can find this. So e to the power minus t square is root over of pi by l a e to the power minus omega square by 4a, and you can see these two are same. And here also this is e to the power minus a mod t 2a by omega square plus a square, and 2a by omega square plus a square. You can see this also same. Now delta function t minus t naught equals to Fourier transform of this is e to the power minus I omega t0, and this one is plus. You can note it down. Okay. T to the power I omega naught t is 2 pi delta omega minus omega naught, and 2 pi delta omega plus omega naught. 1 by t square plus a square is pi by a e to the power minus a omega. These two also same. Cos function you can also note like that. So you can remember one is minus in delta function and this is plus in delta function, and here also one is minus in delta function, one is plus in delta function. Okay, and now between these two we use plus sign, and before that we use pi. Okay, now for sign we add I. Okay, one is plus, one is minus, one is now here is minus sign. Now you can see the change in this two definition. Using this two definition is, in first we take minus and here plus, but the sign between these two is remains the same. Okay, so how to remember that when formula being changed when we take first definition and second definition? See that for the even function like e to the power minus at square, this is what, e to the power pi by a, e to the power minus omega squared by 4a, and this also same. Now this, for this also these two are same. Okay, now you can see that the function which are even function, for that the using both definition we get same result. Okay, so डायरेक्ट डेल्टा फंक्शन के लिए अलग हो जा रहा है. So this one is minus and this one is plus. Using first definition we get minus, using second definition we get plus. And similarly e to the power I omega t, here is minus. First definition, using first definition we get minus, and using second definition we get plus. Now you can you note that e to the power I omega naught is not neither even function nor a odd function. Now 1 by t square plus, you know, this function is have a name which is Lorentzian function. Okay, Lorentzian. Okay, so you can remember this table for easy calculation. Now I will show one example, but for this example you have to know some properties of Fourier transform. I will not note it down separately because it will be, I think it will be difficult to remember like that. So while I will calculating, while I will doing calculation of this question, I will show you the properties. Okay, so properties, how we can solve this. You see there is a property named modulation property. So what is this property? Function of ft sine, okay, I think sine at equals to I by 2 g omega plus a minus g omega minus a. This will be using definition 1. Okay, and another formula, you will write this here, and here will be a minus sign, and by 2 g omega plus a minus g omega minus a. This is using definition 2. Okay, so now I will solve this. First of all, you people think how to solve this. Try to make similarities between these two. Okay, so you can find similarities between these two. So we have to use definition 1. So this formula. Okay, so here in our question, if t is what? If t is, say, e to the power minus 4t square, and sine 3t is what? Sine 80. So we'll write this answer equals to I by 2. I'm doing using shortcuts, okay. I'll just write the formula, minus in between this 2. Here a is what? A is 3. You can see here is a, here is 3. So I by 2 g omega plus 3 minus g omega minus 3. So now what will be g omega? G omega will be what? Now you can see the table. G omega, for g omega. G omega is function of Fourier transform of function of t. So recall Fourier transform of e to the power minus 4t square. Recall from the table using definition 1. Root over of pi by a e to the power minus omega square by 4a. So root over of pi by you can see here is there is also minus sign. So root over of pi by 4 e to the power minus omega square by 4a. E to the power minus omega square by 4 into a is what? 4. Got it? So this is g omega for our calculation. So g omega plus 3, you can calculate what will be g omega plus 3. To the power minus omega plus 3 the key whole square 16. Okay. Sorry, 16. You can also find minus for minus sign like that. So put this in this formula and you will get the answer. So what will be the answer? Answer will be I by 2 root over of pi by 4 e to the power minus omega plus 3 e whole square divided by 16, and in between this two minus sign e to the power minus omega minus sign is 3 whole square omega minus 3, okay, write it like omega minus 3 whole square plus 16. This is the answer. Now you can simplify omega plus 3 whole square is omega square plus 6 omega plus 9, and omega minus 3 whole square is omega square minus 6 omega plus 9 using a plus b whole square formula. Okay. It's not necessary, okay. You can take it common. I will do simply take the common, okay. Only the which term into the power minus omega square plus 9 by 16, and 2ab part we will take only this term common, okay. Other there will be minus and 3 omega by 8 minus e to the power 3 omega by 8. So what will be this? This is say hyperbolic function. What? Sine hyperbolic function. So I will finally write the answer. So this is square plus 9 by 16 minus 2 sine. You can see the formula in the net also. otherwise the video will be too much lengthy. Okay, so this is like that. So for today I will stop here. Thank you.